Hello and welcome back. In our previous video, we got introduced to a new friend called as Chokidar, which would help us monitor changes in our C files. And whenever we make some changes and save those files, it can run a command of our choice. In our case, we wanted to compile and run the compiled executable. With its help, let's dive into the world of test-driven development. Okay, we are in Visual Studio Code, and in our previous video, we mentioned that there are so many files, right? Instead of one single main.c file, there are so many files. So first, let us get acquainted with those files and understand why we have created so many files. In the previous videos, we had done everything in this file, main file, isn't it? We had the implementation of isPrime function and all the tests as well, everything put together in main.c file. That's okay if we are just implementing one function and testing it. But in real world, any application, right? So you will have hundreds of functions, isn't it? Not just one function. Because applications at the end of the day are nothing but composition of multiple functions, isn't it? So that means that we cannot put all those functions in one single file and all the tests as well in this file, right? So it becomes unmanageable. We can't scale with that approach. So how do we face the complexity? We have to go for divide and conquer, isn't it? That is the exact thing we have done here. So what I have done is, now the main file does not have anything in it. It just invokes some test function called as test prime. That's it. Where is it? It is in a module called as prime.test. Okay, we have included this header. This is how we do modular programming in C language, isn't it? So the prime function now is in prime.c, this module or file. So it is the same function except that I have removed all the implementation. Okay, we will implement it. So right now it does not have any meaningful implementation except one line which simply returns false. So whatever input you pass, it simply returns false. And there is a header for that so that we can link this. We can use this function elsewhere. So we need this prototype of that function available. So that is made available in this header. You might see it this is the typical header guard, right, which protects multiple declaration error, right? So that error can be averted using these header guards. Study about header guards in C, right? So I will leave it as an exercise. Anyway, so now this is the module which contains the prime function implementation, and we are having another module called as prime.test.c, right? This is a convention we will be following. Okay, so all tests related to the module will have a word test in their name, right? So prime, that's the original module's name, .test.c, so that you can easily relate, hey, this file is going to contain all the tests which tests functions in this module, right? So it is understood. So same thing. So there is this test prime function inside this prime.test module. So for that we have this header. That's it. It's as simple as that. We have just divided that into correct places. So test related code is going to go into prime.test module, and implementation of isPrime is going to the prime module, right? Of course, you can implement some other functions related to prime numbers also in the same module later, right? Right now we have only one function that suffices for our study. Great. So how do we include them? We simply include the header and simply call them. That's it. We have to do nothing else. So I have our hero Chokidar running, right, and monitoring our files. So as we learned, just saving, right, will invoke this command, right? So Chokidar will invoke the command that we have supplied. It will simply execute it. That is what is going to happen. So let's save. So immediately it detects the change and ends up, compiling and linking all the files in this current folder. and run the executable for us. Of course, seems like some assertion is failing. What assertions we have? Let's go and look at the test prime function in prime.test module. Look at this now, right? So we have so many assertions. Each of these is a test case, isn't it? So we are testing 0, 1, 2, 3. We have chosen some of the inputs, right, which represent a wide range of inputs that we can use to meaningfully test isPrime function, okay? So 0, 1, 2, 3, 4, 5, right? Some initial numbers, right, that we are 100% sure that whether it is a prime or not, right? Of course, you need to be careful when you write tests. You need to do due diligence. So 0 is not a prime number, 1 is not a prime number, whereas 2 is a prime number, 3 is a prime number, 4 is not a prime number, 5 is a prime number, 11 is a prime number, 47 is a prime number, right? And 91 is a prime number. 91 is not a prime number, sorry. 997 is a largest 3-digit prime number. 9983 is the largest, for example, one of the largest 4-digit prime number, and so on and so forth. This is 5-digit, a largest 5-digit prime number. 100 and 1000 we know they are not prime number. So again, we have added some random to bring in some randomness here, right? So we have chosen these many candidates, inputs, and we have written these assertions, isn't it? So now we can actually go ahead and save. The moment we save, again, it is going to detect now the change in prime.test.c and it's going to run and execute. We see the same assertion is failing. This assertion is failing. Surprisingly, first two assertions are passing. Why? The reason is if I go into this, it is quite evident that it is returning false, so it should work, isn't it? So now how do we satisfy this assertion? Of course, we can check, isn't it? So if number is equal to 1 or number is equal to 2, always return false, right? If number is equal to 2, our expectation is that we should return true, isn't it? Let's see whether this passes the assertion or not. So it detected the change. What is happening is that this assertion seems to still fail. If number, okay, so it had to be number 1 or number 0 because of this error, isn't it? So let's go ahead and fix that. Great. The moment we do that fix there, again, Chokidar senses it and runs the command for us. Now, first 3 tests are passing. The fourth one, that is isPrime 3, is failing. Obviously, it has to fail, isn't it? Because there's no implementation for that. Otherwise, we end up returning false. So because of that, it is failing. So do you get the taste of this now? Right? I am pretty sure you got the taste. We will continue with this and actually implement the logic for isPrime step by step. But we will do that in our next video. Stay tuned. Thank you.